Hello. Yeah, good morning, fans. It's been quite a while since we met. Happy New Month, family. All right, let's look at this problem. Though it's an old question anyway, it has been going around the net. It's more like the questions that have been posting around the Facebook for a free Wi-Fi network. That the first three digits is the password to the Wi-Fi. So let's see how we can solve this problem swiftly. And again, let's see how the even and the odd function plays a vital role in this problem. Now, we are going to make an assumption. Let's see. Let our integral I be integral of minus 2 to 2 of f of x dx, where f of x is nothing but this function x cubed cos of x over 2 plus half the square root of 4 minus x squared, right? Yes, we have this. Let's try to expand this function. Let's clear the brackets. So what we have here now is x cubed cos x over 2 square root of 4 minus x squared, then plus half integral, 4 minus x squared. Yes, this is what we get here. Now let's try to apply this even property now. If we subdivide this function now into two parts, f of x equals to f1 of x plus f2 of x. Now f1 of x is nothing but the first function x cubed cos x over 2 multiplied by square root of 4 minus x squared. And f of 2 is nothing but half square root of 4 minus x squared. Now, let's apply the property. Now, we know that for odd, f of minus x will be equals to minus f of x. So, let's try it. From replacing x here as minus x, f1 of minus x will become minus x to the power of 3 cos of minus x over 2 multiplied by 4 minus x to the power of 2. And we know that this will definitely give us this. Which is minus f1 of x, implies that this is an odd function. Yes. Alright, let's look at the second function. f2 of minus x will give us nothing but the same function, f of minus x squared. This will give us half square root of 4 minus x squared. Now, how does this even and odd function apply to this? For a primitive function, that is, for integration, the integral from minus a to a of f of x dx, where f of x is an odd function, gives you 0. Yes. So integral, when the boundary limits are equal, are the same but just opposite in signs, like this case, minus 2 to 2, right? This gives you 0. So automatically, it tells us that by the time we substitute back this function here, this first part, this integral is 0, meaning this implies that integral minus 2 to 2 of x cubed cos of x over 2 plus half multiplied by 4 square root of 4 minus x squared dx will be nothing but half integral of minus 2 to 2 square root of 4 minus x squared. And if we let y to the square root of 4 minus x squared, you can look at this that this is just nothing but a cycle of radius 2. Yes, of radius 2. That's very correct. Of radius 2, which we can definitely now find, or we don't need to go with this. You can look at your substitution to evaluate this integral. Replace x as 2 sine theta. If you do this, you will definitely have something beautiful coming out of there. So, if that is the case, the x will be 2 cos theta d theta, the integral half of minus 2 to 2 of square root of 4 minus x squared dx will be nothing but half times 2 integral 0 to 2 of square root of 4 minus 2 sine theta all squared multiplied by 2 cos theta d theta. And we know that from this boundary limits, okay, let's leave it, we'll still take it back. So this will give us integral 0 to 2 square root of whatever we have in there will still be 2 cos theta multiplied by 2 cos theta d theta. This will give us 4 integral 0 to 2 of cos square theta d theta. And we know from one of the trig identities that cos square theta can be written as half into cos 2 theta plus 1. So we substitute this will give us 4 upon 2, then integral of 0 to 2 of cos 2 theta plus 1 d theta. This will result us to 2 in the bracket of sine 2 theta over 2 plus theta, integrating from 0 to 2. But this limit is not the direct limit for that. So let's return back to our board. We record that x is 2 sine theta, so that as x equals to 0 now, theta will be equals to 0. As x equals to 2, theta will be equals to pi over 2. So this limit now runs through from 0 to pi over 2. 0 to pi over 2. So this is what we should have had here after the transformation. So this will give us, on substitution, when you put 0 here, pi over 2 here, 2 of pi over 2 is pi, and pi is 0. So we just have pi over 2 plus 0. Yes, or rather, minus 0. And this will resolve us to just pi. And pi has a value 2.142. So the first 3 digits here is 314. So that becomes the password to the Wi-Fi. Thank you. See you soon.